I hope you all are fine. So in this live session we will discuss second chapter, scalar and vector quantities. So now in this video we will learn about the scalar quantities and vector. Scalar and vector. Let us start. A scalar. What is a scalar? A scalar, those physical quantities which requires only magnitude but no direction for their complete representation are called a scalar quantities. So suppose any physical quantity we have, and that physical quantity only the magnitude have but no direction present in that quantity, then we can say that quantity is known as a scalar quantity. Suppose distance. So distance have a magnitude but no direction. Speed also have a magnitude, no direction. Work also, mass, density. So these all are the example for a scalar quantities. A scalar can be added, subtracted, and multiplication are multiplied are divided by simple algebraic laws. Now, so point, next topic which we have, tensor. Tensor are those physical quantities which have a different values in different direction at the same point. Tensor is a physical quantities. Tensor are those physical quantities which have a different values in different direction. So whatever the physical quantities are here, so they have a different value as well as the different direction. Means the whatever the magnitude they have, the magnitude is different as well as the direction also different at the same point. Now, so for that example, moment of inertia, radius of gyration, modulus of elasticity, elasticity, pressure, stress, conductivity, resistivity, refractive index, wave velocity, and density etc. are the example of tensors. Magnitude of tensor is not unique. So here in the tensor, so whatever the physical quantities are here, so which have a different values as well as a different direction at a same point, so that is known as a tensor. And tensor example is moment of inertia, radius of gyration, these all are. Now next which we have vectors. So vectors, those physical quantities which requires both magnitude as well as the direction for their complete representation and follows vector law are called vectors. So in the vectors, vector quantities both will present magnitude as well as a direction will present, then we can say this is a vector quantities. Now for this vector quantities example is velocity. Velocity is a example for the vector quantities. Then displacement is also a vector quantities. Weight is a vector quantities. So these all are the vector quantities examples. Now polar vectors. So here we are going to discuss types of vectors. So vector has classified many classified into two types. One is a polar vector, another is aerial vector. One is a axial vector. First is a polar vector, another is a axial vectors. So polar vector, those vector have a straight starting point or a point of applications as a displacement, force etc. So polar vector is known as a where the starting point is there and displacement and force also. Applications such as displacement and force. So from the initial point we are applying the force And axial vector, these vectors represents rotational effect and act along the axis of rotation, and in accordance with right hand screw rules such as angular velocity, torque, angular momentum, etc. So for axial values, we are using the right hand rules, right hand screw rules such as angular velocity, torque, and angular momentum, etc. Other types of vector. So other types of vector: equal vector, negative vectors, and zero vectors are null vectors. So we will discuss each and every. So let us start first one, equal vector. Equal vector means in this equal vector we require two vector of equal magnitude and having same direction are called equal vector. Now here you can see vector A and vector B is given and both in a same direction and both are parallel to each other. That's why we can say these are the equal vector. Now second one is the negative vector. So two vectors of equal magnitude. So magnitude are equal to each other, but the direction is opposite to each other and they are parallel to each other, then we can say this is the negative vector. So opposite vector A is positive one is represented as a vector which is a vector opposite to the vector A, so we can write minus A. Now next one, the zero vectors are null vectors. Zero vectors, this vector as a vector whose magnitude is 0, known as a zero or null vector. Its direction is not defined, it is denoted by 0. Suppose if we have a rope and two boys is applying the force opposite direction to each other, then these force will added to each other and e- LHS equal to RHS becomes 0, then we will say that is a zero vector. Suppose f1 plus f2 equal to 0, then that is called as a zero vector. Velocity of a stationary object or acceleration of an object moving with uniform velocity and resultant of a two equal and opposite vectors are the example of null vectors. Now next one, unit vector. Unit vector, a vector having unit magnitude is called a unit vector. A unit vector in the direction of vector A is given. So A cap equal to A upon A. A unit vector is unitless and dimensionless vector and represented direction only. So here the unit vector, in the unit vector it is a dimensionless. So that's why we are representing represents it the unit vector represents only direction. Now next one, orthogonal unit vector. The unit vector along the direction of a orthogonal axis, that is a x-axis, y-axis, and z-axis are called orthogonal unit vector. They are represented by the cap I, cap j, and cap k. So here y-axis along with the x-axis cap I, along with the y-axis cap j, along with the z-axis cap k. So three vectors are here: x vector, y vector, and z vector. So j cap, k cap, and I cap. Now next, co-initial vector. In the co-initial vector, vector having a common initial point or a starting point, that is known as a co-initial vector. Suppose we have a 3 vector, 4 vector, 2 vector, and each and every vector have a similar starting point. So that is known as a co-initial vector. Suppose here you can see in the figure, O is the origin for the vector A as well as the vector B. Suppose another vector is here, vector C. So three of them, the initial point is O. So that's why we can say, or we can call as a co-initial vector. Now next one, collinear vector. Next one, collinear vector. Collinear vector having equal or unequal magnitude but the acting along the same or parallel lines are called collinear vector. Now here in the collinear vector you can see the figure A and B. So in the figure B, both are equal to each other, both are parallel to each other, but they are not equal to each other. So in the collinear vector, it may be vector having equal magnitude or unequal magnitude acting along the same or parallel line. So they in the collinear vector, whatever the vector will be here will be in the collinear. So the all vector are having equal magnitude or unequal magnitude, and they acting along with the same path, same direction, and they are parallel lines to each other, but their magnitude is not equal. It may be sometime equal, it may be sometime unequal. Suppose in figure number A you can see the vector A and vector B. So both are in along with the one line, and vector A magnitude is equal to vector B magnitude. So now next one, coplanar vector. Coplanar vector acting in the same plane are called coplanar vector. So whatever the vector acting in a same plane, suppose here figure number A. So in the figure number A, vector A and vector B uh, is in a same plane, so it is called a coplanar vector. Now localized vector, a vector whose initial point is fixed, is called a localized vector. So localized vector means the initial point always fixed. Whatever the vector will be there, then the initial point is fixed. So that is known as a localized vector. Now non-localized vector are free vector. In that non-localized vector or free vector, the initial point is not fixed. That is known as a non-localized vector or free vector. Position vector. Position vector, a vector which gives position of an object with reference to the origin of a coordinate system is called position vector. It is represented by a symbol R. So we know that the coordinate system. So how many coordinates we have? We have 4 coordinates. Yes or not? So in that fourth coordinate, so in position vector, we must have to consider the coordinate system and position vector. Here in the position vector, the position of an object with a reference point to the origin of the coordinate system. So now here O is the origin of coordinate system, and y axis and x axis, between the y and x axis the position vector r. So between the position vector r and the vector a and vector a and axis x axis, creating an angle, that angle is theta of a. So displacement vector. Next, which we have displacement vector, the vector which tells how much and in which direction all all object has changed its position in given interval of time is called displacement vector. So in the displacement vector, the vector which tells how much direction uh, an object has changed its position in given interval of time. Displacement vector is the straight line joining the initial and final position. Joining the initial and final position and does not depend on the actual path undertaken by the object between two positions. Now you can see here, along with the x-axis and along with the y-axis, between both axes the vector is present. So vector position vector at t r base 2 and vector position vector at t r base 1. So here tail vector r2 tail and r1 tail is joined at a point, initial point, and then vector a b, another vector displacement vector del r. So these all are depending on the actual path undertaken by the object between the two positions. So the displacement vector for AB is del r equal to r2 minus r1. So that's all in this video. So tomorrow we will discuss about the addition vector. In the addition vector we will discuss about the triangle. So many topics which we have in the vector and a scalar and vector quantities, a scalar and vector quantities. So thank you for watching this video. Please watch, please share my video, like my video, and subscribe my channel. Thank you everybody. Good night.